torchtitan is currently in a pre-release state and under extensive development. Currently, we showcase pre-training Llama 3.1, Llama 3, and Llama 2 LLMs of various sizes from scratch. To use the latest features of torchtitan, we recommend latest PyTorch Nightly. torchtitan is a proof of concept for large-scale LLM training using native PyTorch. It is, and will continue to be, a repo to showcase PyTorch's latest distributed training features in a clean or minimal code base. torchtitan is complementary to, and not a replacement for any of the great large-scale LLM training codebases such as Megatron, Megablocks, LLM Foundry, DeepSpeed, etc. Instead, we hope that the features showcased in torchtitan will be adopted by these codebases quickly. torchtitan is unlikely to ever grow a large community around it. Our guiding principles when building torchtitan: designed to be easy to understand, use, and extend for different training purposes. Minimal changes to the model code when applying 1D, 2D, or soon 3D parallel. Modular components instead of a monolithic codebase. Get started in minutes, not hours. Intro video. Learn more about torchtitan in under 4 mins. Dive into the code. You may want to see how the model is defined or how parallelism techniques are applied. For a guided tour, see these files first. Train.py, the main training loop and high-level setup code, torchtitan/parallelisms, parallelize-llama.py, helpers for applying data parallel, tensor parallel, activation checkpointing, and torch.pile to the model, torch-parallelisms, pipeline llama.py, helpers for applying pipeline parallel to the model, torchtitan checkpoint.py, utils for saving loading distributed checkpoints, torchtitan float8.py, utils for applying float8 techniques, torchtitan models llama/model.py, the llama model definition, shared for llama 2 and llama 3 variants. Key features available: FSD2 with per-param sharding, tensor parallel, including async TP, selective layer and operator activation checkpointing, distributed checkpointing, including async checkpointing, checkpointable data loading with the C4 dataset pre-configured, 144M entries, loss, GPU memory tokens per second, and MFU displayed and logged via TensorBoard. Learning rate scheduler, meta init, optional, fused RMS norm float8 support. How to: torch.compile support DDP and HSDP. All options easily configured via TOML files, interoperable checkpoints which can be loaded directly into TorchTune for fine-tuning. We report our performance verified on 6428 GPUs. Coming soon: pipeline parallel and 3D parallelism. Context parallel installation. Git clone/github.com/pytorch/torchcd torchtitan pip install-r requirements.hex pipe3 install pre-torch-index URL slm /downloadtort.org/whl nightly/cu121 or cu118. Downloading a tokenizer. torchtitan currently supports training Llama 3 8B 70B and Llama 2 7B 13B 70B out of the box. To get started training these models, we need to download a tokenizer.model. Follow the instructions on the official MetaLlama repository to ensure you have access to the Llama model weights. Once you have confirmed access, you can run the following command to download the Llama 3, Llama 2 tokenizer to your local machine. Get your HF token from hhuggingface.co/settings/tokens. Llama 3 or 3.1 tokenizer.model Python torchtitan/download tokenizer.py, repo ID MetaLlama 3.8b, tokenizer path original, HF token equals Llama 2 tokenizer.model Python torchtitan/datasets download tokenizer.py, repo ID MetaLlama/llama 13b HF token. Start a training run Llama 3.8b model locally on 8 GPUs. Config file /train configs llama 3.8b.toml /run llama train.sh. TensorBoard. To visualize TensorBoard metrics of models trained on a remote server via a local web browser, make sure metrics.enable TensorBoard option is set to true in model training, either from a TOML file or from CLI. Set up SSH tunneling by running the following